let's talk about remainder estimate, okay? Basically, like we're gonna try to estimate the series, okay? So what is series? AN is equal to A1 plus A2 plus A3 plus, and keep adding AN, and we cannot stop here. We have to keep adding forever, which means there is no way to add this one forever. So like what we're gonna do is we're gonna try to estimate this one with good summation. I mean like partial sum, okay? So what we're gonna do is we're gonna use the first n term, which is Sn as the approximation of the series. Is it okay? Then after like you choose this one, then what about the like leftover? I'm talking about this part, okay? We're gonna say this is Rn, which is remainder. Is it okay? So think about it. If you can make your Rn part as small as possible, then we can say your Sn is good approximation for your series, right? So like, you know, that's why like we're gonna try to control your remainder part, okay? Which is like also with error, okay? So let me give you the figure of this, okay? It might be much easier to understand, okay? So basically, whenever you think about the graph of series, and you will consider the like, you know, corresponding function, right? So definitely your corresponding function is continuous and positive and decreasing like that. It's too dramatical, right? So let me draw it again. Positive, continuous, and decreasing, right? So what is S1? S1 is this rectangle. I mean, A1, okay? And A2 is this area. A3 is this area, okay, and so on, okay? So look at that. Since your graph is like getting like, you know, narrow, which is getting close to x-axis, okay? So like the very last tail part is like a very small amount, right? So we're gonna add up until n. It should be better to extend this line, okay? Until this rectangle. Then as I told you, I'm gonna use this part as the approximation of the series. Is it okay? Then what are left over? Let me try to like enlarge this part, okay? Even it's very thin, we still have the rectangles, right? Right? So again, we would like to make this one like to the like desired error inside of like under the desired error, okay? And also important thing is when you add up a n plus 1 and a n plus 2 and dot dot dot, and do you agree with me that area of the rectangles are under the area of the curve? Is it okay? So we can say your Rn is always less than or equal to integral n to infinite with corresponding function. And we're gonna try to control this one less than error. In other words, if your improper integral with the like from n is less than the error, then I can say my remainder, which is Rn, is less than error. Is it okay? This is the way to like control the like, you know, the estimation with the like, you know, like desired error, okay? So like, let me give you one example for this, okay? Here we go. So what is smallest value of n? For sure, your sum of the series with error less than 0.05, okay? So basically we're gonna use the n term, which is Sn as approximation, and we will talk about like from n to infinite as the remainder, and we're gonna set that less than 0.05, right? So the remainder Rn is always less than equal to integral n to infinite with corresponding function, right? And we would like to make, this is my target, okay? So let me take care of the improper integral first, okay? So this guy is equal to limit t goes to infinite integral n to t 8 over x plus 2 cubed dx, right? And since I don't like the coefficient, let me put that out. And what is that? N plus 2 to the negative 3 power, right? Which means 1 over -2 and x plus 2 -2 and 2 t. Okay, so let me pull out like another coefficient which is -2. It is -4 limit t goes to infinite. When I plug in t, it is 1 over t plus 2 squared minus 1 over n plus 2 squared, right? And since t goes to infinite, we know this part goes to 0, right? So that is equal to negative, which is positive 4 over n plus 2 squared. And we would like to make this one as less than 0.05. Is that clear? And let me write it like 0.05 as a fraction, which is 5 over 100. And it is 4 over n plus 2 squared is less than 1 over 20, okay? Let me divide by 4 on both sides, okay? 1 over n plus 2 squared is less than 1 over 80. Then let me flip. It is n plus 2 squared is bigger than 80, right? So which n plus 2 is working for this one? As you know, 5 squared is 25, oh, less than 8, right? And 6, 7, 8, 9. There we go. When n plus 2 equal to 9, 9 squared is 81, which is bigger than 80, right? So I can say the smallest value of n plus 2 is 9. That means your smallest value of n is 7, because 7 plus 2 is 9, right? So like, what does that mean? When n is 7, which means S of 7 is the approximation of your series, which error is less than 0.05, okay?